Okay, so today we're going to be solving linear systems by graphing. You should have had a note sheet handed to you that goes along with this video. You're going to want to write this starter down somewhere. We are going to practice solving into slope-intercept form from standard form. So remember that our first step here would be to subtract 2x from each side. Bring down your negative 3y equals negative 2x plus 9. And then we're going to divide each side by negative 3. Y equals a negative 2 divided by a negative 3 would result in a positive 2/3 x minus 3. So remember, then we could start at our y-intercept and use our slope to graph our line. So like I said, today we're going to be solving systems of equations by graphing and then determining the number of solutions in the system. If you remember from class yesterday, a system of equations is two or more linear equations with two or more variables. Today, both of those variables are going to be y and x. And the solution to a system is the ordered pair that satisfies both equations. More specifically, today we're going to be looking for the point where the lines intersect on the graph. All right, so here's our first example we're going to look at. We have these two given equations here, y equals negative 2x minus 3 and y equals 2x plus 1. And we are going to be graphing those two, but first let's fill in. What do you notice about those two slopes? They are different. Y-intercepts may or may not be the same. When graphed, these two lines are going to intersect. There's going to be one point where they intersect, so there's one solution. So let's go ahead and graph these two lines to find that solution. So I'm going to start with the first one, y equals negative 2x minus 3. Remember that you start down on the y-axis at negative 3. And then we have a slope of negative 2, so we are going to go down 2 and to the right 1. And do the opposite and go up 2 to the left 1 to continue our line. Once you have enough points, go ahead and draw your line. And if I'm going too fast for you at all, remember that you can pause this video, you can rewind it and watch it again and again if you need to. Okay, we're going to graph the second line, y equals 2x plus 1. So we're going to start at 1 for our y-intercept on the y-axis. And we're going to rise to run 1 for our slope and do the opposite down to left 1 in the other direction. Go ahead and connect those lines. And remember that what we're looking for here is the point of intersection between these two lines. So on our graph here, we see the point where they intersect is at the point negative 1, negative 1. So our solution is the point negative 1, negative 1. And this particular system of equations had one solution. Let's look at our middle line here. So we have two equations, y equals 2x minus 3 and y equals 2x plus 1. We've already seen this year that when two equations have the same slope and different y-intercepts, that means those lines are going to be parallel. The slopes are the same. The y-intercepts are different. When graphed, the two lines are parallel. And since they are parallel, remember parallel means they will not intersect. So there is no point where they intersect, so there will be no solution. Let's go ahead and still graph these two lines. Y equals 2x minus 3. We're going to start down on the y-axis at negative 3. Slope of 2 means rise to right 1. Then go ahead and draw your line. And then we'll graph our second line here. Y equals 2x plus 1, so we're going to start up 1 on the y-axis. Slope of 2, so we're going to rise 2, go to the right 1. Down 2, left 1. And you'll notice as we're graphing these lines, these two lines are never going to intersect here. They are parallel, so therefore our solution is no solution. So far we've seen a system of equations that intersected and had one solution. Here's an example where they did not intersect, they were parallel lines and there was no solution. We have one more type, a third type. And let's look at these two equations, our system here. So first of all, you'll notice that one of our equations is in slope-intercept form, but the other is in standard form. So we're going to need to write this off to the side, and we're going to need to solve this into slope-intercept form in order to graph it. So negative 2x plus y equals 1. We're going to add 2x to each side. And we're going to end up with y equals 2x plus 1. And that is the same equation as our first equation. So the slopes are the same. The y-intercepts are the same. When graphed, there's only going to be one line because they are exactly the same line. Therefore, where they intersect is going to be everywhere. So there is going to be infinite solutions. And we'll go ahead and graph this line. Y-intercept of 1, so we're going to start up 1 on the y-axis. Slope of 2 again, so up 2, right 1, down 2, left 1. And these are the same lines, so I'm going to go ahead and put a second set of arrows on this to show that we graph both lines. So our solution here is infinite solutions. These lines will intersect everywhere. That means any point that we pick that's on that line will make both equations true. So there are three possible solution types to systems of equations: one solution, no solution, and infinite solutions. And just remember, when we're graphing, we're looking for the point of intersection. And when we have one solution, make sure that you actually name the solution with that ordered pair. Don't just write one solution. Let me know if you have any questions on this. You're going to be doing a bunch of practice with systems of equations now. Have a great day.